What's that?
We're in chapter 3, right? So, I'm just turned into a page on chapter 3. I don't remember exactly which page we're on, but the thing where you add the first 2 rows to the end of it and do all
Oh,
that.
yeah. Okay. Oh, that weird thing that I do. I wondered which weird thing you were talking about. Okay. We are now recording. Before we get into, well,
I guess it makes
okay,
sense.
slide.
But, it was harder for me to kind of grasp it at first.
Okay. Before we get into the actual class today, I'm almost certain of this. I'm pretty well certain. Next Thursday, 1 week from today, I will be in the air flying to Dallas, Texas. At this time, we've got a wedding in the family, and the activities really start on Friday, and we couldn't get, we have to leave today to be there. In fact, I think some things start Thursday night. So anyway, I won't be here next Thursday. So we talked about before my differential equations class how we could make up the time, and so some of the people are in both classes. 2 of you, I think, are in both classes. No, 3 are in both classes. All 3 of the people in this class are in differential equations. Only one was here to speak for it, and then there was another guy from differential equations who's not in the linear algebra class. He agreed with it too. What we'll do is next Tuesday, before I'm out on Thursday, what we're going to do for the differential equation class is have a double class. So we'll meet at 9:30 and go until 12 o'clock. Okay? Then we'll take a 15-minute break and start linear algebra next Tuesday at 12:15 and go to 1:30. Okay. Then I'm out on Thursday. The next Tuesday, after I'm back, we will have regular differential equations, 9:30 till 10:45. Then start linear algebra as normal, 11 o'clock, but make that a double class and go that until 1 o'clock. 1:30. And that way we'll make up both of those classes. And then a sad thing coming up is in November we have to do it again because I've got a doctor's appointment on November 8th. But we'll worry about that. That's a Tuesday that time. We'll worry about that later. We'll manage that then. Now, sometime in the process, I'll have to make up my Math 112 class, the pre-calculus algebra.
Morning, 8 a.m.
Yeah, 8 a.m. on Thursday. But I've got to, I'll decide with them on Tuesday what we'll do. Because I did want to make sure that the trip is next week. I'm almost absolutely positive it is. But I want to make sure over the weekend that I do have my dates right. All right. So I think we were on page 107. Oh, first, any questions? Anything we've done so far? Okay. We're on page 107, top of the page, expansion by cofactors. And basically, this is summarizing what we had already said. Just pick a row, any row, or pick a column, any column, and then with that column, then multiply it by the cofactors that are left over when you wipe out that row and column, and go down the row or down the column and proceed like that. Now, I'm not going to write all that down. It's all a summation with subscripts and things, and the writing it down does nothing to clarify it in my mind. What clarifies it is actually doing it. So let's do the term example 4. Okay, find the determinant of this matrix. Let me get my pen set up. Forget I have to do that. Okay, here's matrix A. A 4 by 4. We haven't dealt with many 4 by 4s. 1, negative 2, 3, 0, negative 1, 1, 0, 2, a 0, 2, 0, 3, and a 3, 4, 0, negative 2. All right. So here we have a matrix. We want to find its determinant. Okay? Remember, you can choose any row, any column, and move from there. Do you have a preference?
1, 1.
Second?
First row and first column.
Okay, I can tell you like to work real hard.
I mean the last row and first column. Actually, the third row.
Third column. Let's go with the third column, because guess what? In finding determinants, zeros are your friends, okay? And so go with, I'm not saying anything about your friends here, but okay. Let's go with the third column, okay? So basic, okay. All right. So what this says, picking the third column, okay? Now the first thing, here's how I do it. I'm not going to say the book does it exactly this way, but here's how I do. First thing I do is figure out what they talk about cofactors all like this. Just figure out what the sign of that position is. Always start the sign determination upper left. You know that's positive, and that be plus, minus, plus. So it's going to be a plus 3. Okay? 3 times the determinant of what's left over. When you wipe out first row, first column, what you have is a minus 1, 1, 2, a 0, 2, 3, and a 3, 4, negative 2. Okay.
Do we have to do this again?
Okay. You could do that again, or now that you've got it in 3 by 3, you can do the technique for 3 by 3 matrices. Expand those,
Okay,
the thing you don't like to do,
yeah.
right? Okay?
It's the same thing, though.
It is the same thing, but I don't have to worry about my signs. The signs take care of themselves. Okay?
I'll try. I'll give it a try.
Okay. So what I'm going to do is wipe out the second bar, still doing a determinant, but I'm going to cheat a little bit by writing over the first 2 columns. Negative 1, 0, 3, and 1, 2, 4. Okay? And then do your upper left to lower right diagonals. And you're multiplying. Okay, and by the way, the 3 is still out front, and that 3 is multiplied by?
So you're multiplying negative 1 times 2, which is
Yeah.
negative 2.
Now, you don't have to do it my way, but I'll tell you how I do this. First thing I do is count signs.
So there's 2 signs.
2 negatives, that makes pluses. So I don't worry about my signs anymore. See, I try to avoid sign errors. So it's going to be a plus, and then multiply the numbers together, you get 4.
Okay.
Right?
Right.
Go down the next diagonal, as long as it's upper left or lower right. There are no negatives, so this is going to be positive.
That's 9.
9. And then do the last one. And guess what?
0.
0. Yes, zeros are your friends. Okay. Now, minus. And what I'm going to do here is erase my construction lines here because they're now going to be in the way. And do my backward diagonals. Okay, but you have to have all 3. And that would be 12, negative 12, because these are negative. This one will be a,
Negative 12, or it'd be a positive 12.
that would be a plus 12 because,
These are
goodness
negative.
gracious, yeah, these are negative and you have a negative 1. And then this one, yay, is a 0. All right, I think I can do this. Minus 12 plus 12 adds to 0. That would be 13 times 3 is 39. Okay, that's what I get my determinant of A to be.
So
Okay.
that's the determinant of
determinant of A is 39.
And that's it. Okay. But we're not going to be so lucky next time with a whole row of zeros. Do they give us another example to do?
Yes, you like to work, don't you? Okay.
I think A is. See, they're using your thing.
Yeah.
They
On the next page, yeah. This one they did on page 107. They did it with the cofactors and the -1 to certain powers and it's tedious. This way, you just do it. Okay. Now, let's do example 5. This is only a 3 by 3. But guess what? You're not going to have that many huge ones to do. After a while, you do you program them if you got that many big ones to do. So find the determinant of this A. Here's A. A little old 3 by 3. 0, 2, 1.
Matrix A is pretty much the variable X.
Yeah, pretty close. 3, -1, 2. And 4, -4, 1. Okay. Believe it or not, this 3 by 3 is probably, well, no, goodness gracious. I don't know. Guess what? This is a 3 by 3. You don't have to do cofactors of anything. Just do the technique. So, what I'm going to do is remove that last bar there. Okay. And what? You tell me.
You write in the first 2 rows again. So 0, 2.
Okay. First 2 columns. 0, 2, 3, -1, 4, -4. And then you just do the math.
Slice and dice thing.
Okay. And that's going to be, so the determinant of A is going to be 0. Okay, I won't even write that down. That one will be
4, 8,
16. That's positive. This one will be a -12. Okay. Now, because it's easy for me to do here, I'm going to wipe these out. You probably can't do that this easily, but
So, did you, would this be reasonable to put an in parenthesis there and then put a minus sign and then start your next thing and just multiply them?
you could, absolutely.
I feel
You
like
could.
that would be better.
Okay, we'll do that. Minus, and then we'll do all these, and we will do the first diagonal here is a -4. The next diagonal is a 0, and the next diagonal is a
6.
+6. Okay, so this would be,
-2.
okay, this one here will be a 4 minus a 2. That's going to be 2. All right, the determinant of A is 2. Let's see how they did. Oh, look at that. They got it right, too. Good for them. Now, this linear algebra applied here. I don't think we're going to get far enough in Cal 3 to run into these, but there is a thing called a Jacobian. And it was named, I'm pretty sure, after someone whose last name was Jacob. I'm not absolutely certain of that, but it seems like that's true. That's the way these things usually work. And these are your Jacobians, and since we will get far enough to do partials, but I don't think we'll get as far to do Jacobians. These are Jacobians, and they really are useful in a lot of pretty high-level engineering and math and physics type applications. So you can either figure out who it is that came up with this. That would be a potential paper topic, or how are they applied, or what area of your particular field would possibly be these be applied. So I just wanted to point that out. We're not going into it now because most of the people in the class haven't had Cal 3, so we won't do that yet. But it is a good thing to look forward to. All right. Now, we've already talked about some triangular matrices. We called them the good old Lulus, right? Yeah. The upper and the lower triangular matrices. Okay? A matrix that is both upper and lower triangular at the same time, though, has a special name because what's left? Just a diagonal, so we call them diagonal matrices. Okay? If it happens to be both upper and lower triangle, then it's a diagonal matrix. Okay? But all these are called triangular matrices. Now, those are especially nice to do your determinants on because you have lots of zeros, and zeros are your friends, right? Okay. Let's just do this one that they have here. A is equal to this matrix, 2, 3, negative 1, 0, negative 1, 2, and 0, 0, 3. Okay? Now,
that's an upper triangular matrix?
That's an upper triangular matrix, so it is a triangular matrix. How would you suggest going about finding its determinant?
Add on the first two rows.
Okay, you could do that, but
You have a better source.
since you have all these zeros in there,
You could do the bottom row.
either the bottom row or the first column. I don't care.
We can do first column.
Yeah.
Column.
Okay, so let's do first column. And what would that be?
That would be negative 3.
Okay, wait. Don't forget the 2. Sign of that position is plus, so it'd be a 2 times,
Negative 3.
right? And that's 0, right? 2 times a negative 3, which is negative 6. Okay?
That's the determinant.
That's the determinant. It was that easy. But I want to point out something to you. What did we multiply? We wiped out this, and we didn't use that. So guess what we were using?
The main diagonal.
That's all we did. It's the product of the main diagonal. If you had a lower triangular, you choose either the first row or the third column again, and the same thing is going to happen. So any triangular matrix, the determinant is the product of the diagonal.
It's no sort.
It's that simple. So the stuff we were doing before that got you our upper and lower triangulars, guess what? They make finding determinants
It
pretty
can be
easy.
pretty useful.
Yeah, definitely so.
I'm sure if you have like a big, well, is this for only 3x3s?
No, it
Okay,
works
so
for
if you
any
have
of them.
6x6, it might be
Absolutely.
beneficial to.
Oh, absolutely. Well, it's work to get there, but then once you get there, the determinant is real easy to find. Product of that diagonal. Okay? And that's what the theorem 3.2 says. The determinant of a triangular matrix, I'm called 2, goodness gracious. If A is a triangular matrix of order n, any order whatsoever, then its determinant is the product of the entries on the main diagonal. That is, the determinant of A is equal to A11 times A22 times A33 times A ... to ANN. That's all, folks. Okay. So let's do example 6, which I'm going to guess is going to be a pretty easy one. Okay?
You don't.
Here is example 6. Matrix A is 2, 0, 0, 0, 4, negative 2, 0, 0, negative 5, 6, 1, 0, and 1, 5, 3, 3. That is a lower triangular matrix. All right. So let's just imagine we didn't know what that term we just did. What would you choose?
The
first row, and you would choose the 2 here, and then do the diagonal matrix, the 3 by 3 times the determinant of that 3 by 3.
Yeah.
Okay. Then you would choose the 2 again, the negative 2, and do this one, and sure enough, you just get this times this times this times this, because everything else is multiplied by 0. So what's the answer? The determinant of A would then be, got the hiccups, is what? Negative 12. Done. Wish I could make it harder, but I haven't figured out a way to do it. It just makes it pretty reasonable.
That's it.
And that's it for 3.1. So I've assigned most of these before, but here's the reassigning of them. Homework exercises, any of the odds 1 through 11. 11 is sort of interesting. We will hopefully get to using that again later. Either 13 or 15. Do 17. Any of the odds 19 to 30. Excuse me. 31. Do 33. They say you need a graphing calculator to do, or some type of assistant to do 35. You might try that on your own to see what you get. And either 37, no, and or 37. Either 39 or 41 or both. Those are the nice ones. They're triangular. True, false, 43, definitely worth reading through. Don't expect to have too many of those on a test, but still good to think through the issue. 45 or 47 or both.
I don't know if you mentioned the test, but the first test is out.
Yeah, I meant to say that. I'm glad you said that. I'll say it in just a second. Either 47, 49 or both. 45 or 47 or both. Either 49 or 51 or both. Any of the odds 53 to 57. Do 59. Any of the odds 61 to 65. Try 67. I'll say 67 and or 69. Okay, and that will pretty much wrap that up. Okay, and what Cameron was reminding me, we did finish chapter 2 last time. I didn't have the copies made. I had the test made out, but I hadn't gotten copies made. So I did get copies made. They are ready now. You need to somehow get in touch with me of how you want to get your test, okay? Unfortunately, I can't email you your test. Oh, no, wait. I type these tests in word processing package that maybe many of you have never heard of. It's called WordPerfect, okay? The reason I use it, their equation editor is so superior to Word's equation editor. I mean, they're not even in the same ballpark. And the WordPerfect version that I'm using is one from at least 15 years ago, okay? And it's still better than the current Word equation editor, by far, okay? So they're in WordPerfect, so I can't send you an email with the test in it per se. But what I can do is scan the test and send it as a PDF. That doesn't come off quite as nicely most of the time, but since I can't guarantee, in fact, would almost bet that none of you have WordPerfect, I can't email you the test, but I can scan it and send it to you in email if you let me know you want me to do that. Which the reason, huh?
Just come pick it up.
Yeah, or come pick it up. That's probably better, and that way we can talk about things if you have questions. But the other reason I'd like you to request it is that way I'll send it back by the email you prefer. Some of you might want your personal email, your work email, or something like that. All I have for you is a Lawson email, so I don't know if you're checking that or not. So that's the other reason to let me know how you want me to get it to you. So those tests are ready. As soon as you let me know or come by to get it, I'll give them to you. Okay? Or send them to you. All right, let's move on to 3.2. We're now going to look at determinants and elementary operations. Have you ever got the idea that elementary operations are fairly important here? Seems like we do a little bit of something and we go right back to elementary operations. Remind me again of what those elementary row operations are.
Basically, anything you can do to an identity matrix in one move sort of thing.
Okay.
So that's either switching rows,
Right.
multiplying a row by a number, or multiplying a row by a number and then adding it to
Another. Exactly. Okay. So those are the three elementary row operations. How do those affect our determinants? Okay.
I'm sure they affect them a lot.
What's that?
I said, I'm sure they affect them a lot.
Well, actually, it's not as much as you might guess, and we are going to look at those. And the first is a rather dumb question, but they do it, so I'm going to put it down here.
I already know the answer to that question.
Yes, I think you do, but since not everybody has the book in front of them, in fact, some people might not even have this book, so let me write it down for you. We want to find the determinant of matrix A, where matrix A is this, so we're finding the determinant of this. That's why the straight lines mean do the determinant. The brackets mean that is the name of the matrix, okay? Determinant of 1, negative 2, 3, 1, 4, negative 6, 3, 2, negative 2, 4, negative 9, negative 3, and 3, negative 6, 9, 2. Or the determinant of B. And B is also a 4 by 4 matrix. 1, negative 2, 3, 1. First row is identical. Second row, though, is 0, 2, negative 9, negative 2. Third row is 0, 0, negative 3, negative 1. And the fourth row is 0, 0, 0, negative 1. Which of those is easier to calculate the determinant? B by far, okay? Because it's a upper triangular matrix, so therefore just do the product of the diagonal, which is 6. The determinant of matrix B is 6. Now, the surprising thing, I think, and we're not going to do it, well, yes, I guess we are going to do it, okay? Let's do it. Let's do the determinant of A.
I bet I'm going to take a stab at it here.
Yes, and you're right. Now, the next question out of my mouth would be, choose a row or a column. And there aren't really any advantages to any of them.
I'm thinking the top row is kind of okay.
That certainly is. They're fairly small numbers. And earlier you asked for another example of doing a determinant. You asked for it, you got it. Toyota. Okay. So let's do the determinant of A. Determinant of B, by the way, is 6. Okay? Determinant of A is going to be, okay, we're going to do the first row. Is that what you agreed on? Okay. What do you look at first? Sign of the position, and that is positive, and that's just going to be a 1 times, and then you wipe out the first row, first column, and you do the determinant of negative 6, 3, 2, 4, negative 9, negative 3, negative 6, 9, 2. Next.
Go ahead and rewrite those first two rows next to it.
Okay, wait just a second. Let me wipe out my construction lines there. Okay, now what did you say?
Go ahead and write the first two rows next to it.
Okay, we will do that when we actually do the, you want to, let's just write the whole thing out now. What's going to be next? Big picture. No, I mean, you leave what you got there, because I'm going to come back and do it right there, okay? What's going to be next?
-2.
Okay, but first you determine the sign of that position, which is minus 2 is going to be +2 times, and now you wipe out that first row, second column, and you got a 4, 3, 2, -2, -9, -3, 3, 9, 2. Okay? Skip a little bit of space there. And then we do what?
See,
3. Okay. So I'm going to wipe out this. We're using the first row, so I'm going to leave it wiped out. Okay. That means really tired. Okay. The position of 3 is plus minus plus. Okay, it's a +3. And its determinant, when you wipe out that column, is 4, -6, 2, -2, 4, -3, and 3, -6, 2. Okay, I'll leave that in for now. And then we move to the last column, last entry.
This one's going to be a negative.
Yeah, and that's a negative. Got it. Whoops. No. Okay. Okay. So that's going to be a -1 times the determinant of, now we're going to wipe out the fourth column, and what do you have left? 4, -6, 3, -2, 4, -9, 3, -6, 9. Okay. Now, to do what Cameron suggested in the first place, let's do the 3x3s. Okay? I wanted you to get the big picture of what was happening here.
It makes sense.
Huh?
It makes sense.
Okay. So I'm going to wipe out that last line on all these, and then I'll write in, copy the first two columns. -6, 4, -6, and 3, -9, 9. Okay, just so you don't lose it here. And this will be a 4, -2, 3, and a 3, -9, 9. Okay, this will be a 4, -2, 3, and a -6, 4, -6. Okay, close that off kind of. And this will be a 4, -2, 3, a -6, 4, -6. Okay. Did I thought I wiped out that. Did I throw it back? Okay. Now, if it's okay, I'm not going to write down the 1 again, but let's just do our diagonals. And what do they have?
48.
Wait.
Is that a 9?
No, bigger. Yeah, that's a 9. Let me see. Yeah, I think it's a 9.
It is.
A -9, yeah. Okay, and what do you have? 54. Yeah, 108. Okay.
Plus 56.
Plus, and did you say 36? Oh, yeah, no, yeah, you're right. Yeah, 56. 54, isn't it?
Yeah, 54.
54, okay. Goodness gracious. Okay. Last positive diagonal here is?
That would be 7.
Is that right? Yeah, 8 times 9. Right. Okay. Those are our pluses, and they all happen to be pluses. Okay. And that'll be minus times 108. And it is a positive because of 2 negatives. Okay. Yeah. 162? Is that right? No, that doesn't sound right. Yeah. Yeah. Okay. Here's how I do it. 18 is 2 times 9, right? 9 times 9 is 82, double that. 162. And it's a plus. Okay. All right. And then this one is a 24. All right. That just gives me the first matrix. Okay.
30 more to go.
Yes. I'm going to do this one up here. Plus 2. I hope I can find all these at the end. Plus 2 times. Okay.
Actually, I had mine pretty good.
Yeah.
All right. That would be 18.
Huh?
72.
Yeah. Negative 72. Right? Okay. Okay. Then we do this one. 27.
Wait, wouldn't that be positive?
Nope. There's 3 of them, aren't there? No. I'm sorry. I thought that was the top one was a negative 2. You're right. So. Oh, I didn't need that. All I need is a plus there. Okay. Yeah. Wait a minute.
Why does your 3 have a negative?
No, wait. It is a negative. I was right the first time, I thought.
I missed the negative. I didn't have the negative in my matrix.
Okay.
You're right, it's a negative.
Is it negative? Okay.
I didn't bring that in there.
You're playing with a sleepy old man's mind here. Okay. All right. The next one.
That would be negative 18 double, which is 36.
Negative 36. Okay. Then we have our minus, open parentheses. And let me wipe out my construction lines here so it'll be easier to see. And let's do the, yeah. And they're a little messy because I didn't write this one too neatly. But that's going to be a minus. 54. And then that one's going to be a minus. Okay. Oh, yes, 108. Goodness gracious. The old brain's not working. Minus 108.
Yeah, when you start.
And this one would be another minus. 12. Okay.
I like keeping them low.
All right. Now.
3.
I don't have any room. What I think I'll do is wipe out B up above. Okay?
Okay. And then you can write for us your answer
Okay.
You wipe out that over too.
Okay. Well, I've got the eraser here. Yuck! I don't have the eraser here. It went to a laser pointer or something, whatever the little shiny thing is. All right. So we have a plus 3 times.
And that would be 32.
32
plus
plus
18 times 3.
do it 9 times 6. It's easier. Yeah. Right? And then you like to work too hard. I can't help it. Okay. Plus.
72.
All right. Wait a minute. Is that 2, 2, and 6?
Yeah.
4 times 6.
Oh, I thought it was a 9. Okay.
Okay.
Yeah. 24.
24.
Then negative.
Minus. Now let's do the back diagonals.
24. Plus.
Okay, you're ahead of me. Okay. Okay, we got a positive 24 and a positive 12 times 6 is 72. And then we have another positive 24. Okay, and then we have a minus 1 times 72 plus that's not pretty anyway. 54 times 3 would be 162.
I think so.
Okay. And then the last one's also a plus. 36. Is that right?
No, we have the wrong one here.
What's that?
Negative 6 for that bottom corner.
Yeah, but a negative 2 in the middle, isn't it?
I didn't see the negative.
Okay.
All
All right.
okay. So that'd be 18 times 2.
Huh, 36. Okay. All right, then I'm going to wipe those. All right. And we'll do the back diagonals, which will be a minus. That's a 36
And then plus.
plus, and that's 54 times 4.
So it'd be 216.
I think so. And another plus. 12 times 9 is 108.
12 times 9
Right?
Sure.
Okay. Now let's do these as smartly as we can. Here's a 108 and a minus 108. Those are gone. Okay, let's see if there's any more like that we can do. Unfortunately, none there.
24 and 24 on the 3 times one.
Okay, plus 24, minus 24 there.
36 and 36 on the
36 on that one. All right.
And I think that's it.
Yeah, I'm afraid so. Okay. So we have,
So,
yeah. This looks like a 126 minus, that looks like a 186. Do you agree? Okay, so this comes out to be a negative 60. Okay.
Which one is that?
That's the first at the bottom.
Negative 60.
Is that what you get? Okay. Taking my word for it. I've got some. Never mind. Okay. So that looks like a 99. That won't help me any. Let's do these two together. This is a minus 63, and this will wind up being a plus 54, so that's going to be a minus 9, I think.
Right.
Okay. And then we have a...
Plus 12, which one is that? 3.
What's that?
Add
Yeah.
12 to it, you get 3.
And you get a plus 3, but that's going to be a plus 3 there.
Yeah.
Okay. And then 72, minus 72, and that is going to be a minus 36.
Yeah.
Plus 3 is minus 33. I hope I'm doing this right.
No,
And
wait. That would be a positive 36.
you're right.
So
So
that'd be 39.
39, plus 39. Yeah. And double that and you get a 78. So these two together give you 18. All right.
We're getting closer.
Yeah. These two together give you an 86, and a minus 72 would be 14.
Yeah.
Okay. And then
You said
a
86?
yeah.
12.
Okay.
No,
No,
it's
it's-
14. You said it right.
Yeah. Okay. And then 14 and a minus 24 is a minus 10. Multiplied by 3 is a minus 30. Okay. So those two together come out to 12. Negative 12. Okay. And then let's see what we've got here.
Should be a positive 6.
Okay. We hope. Okay.
That'd be so bad.
So 72 and 162 is 234.
234.
And this is a 24. Is that right? It seems like
Negative 110.
negative 110. No. Negative 90, isn't it?
Yeah.
Negative 90. And that makes it a plus 90.
90 plus 12.
Nowhere close. Oh my! You wanted one of these. Let's see. They did do some things right. Let's see. 1 times a negative 60, we got that. Plus 2 times a 39. We did get 39. I think we forgot to do 39. No. Okay, we did that. 2 times 39. Yeah. And then a plus 3 times a negative 10. And we got negative 10. Okay. It's that last one. Minus 1 times a, they say a minus 18. And that's way off. So I'm guessing, and which one was this? This is that last one. That last one. And I think it's the minus side that probably is messed up, and that's the one we've got here. So that's 9 times 4 is 36. and that's 24 times 9. 216. Yeah, that's right. And then the last one is 12 times 9 is 108. So it must be our pluses that are out. So let me clear our pluses.
That first one should be 144 instead of 72.
Ah, that's it. That probably will do it for us. Well, do the eraser. Okay, that's a 144.
Yep.
I'm guessing that will do it for us, huh?
The next one's right.
Okay. 144. I think we'll be fine then. That adds up to be 306, right? And then, yeah, and subtract that from 324 and you get minus 18. Which then you multiply by minus 1 and you get plus 18. Plus 18 minus 12 is plus 6. Yes. One little error.
Let's just be glad it wasn't earlier. More of them.
Yeah, exactly.
But yeah, I think it would be much easier to try to get it into blue form.
And the suggestion here is that matrix B that we just did is obtained from matrix A by interchanging, I'm sorry, different A's and B's. Sorry about that. But here's what I'm going to tell you. Matrix B above is produced by a series of elementary row operations. Okay? And we happened not to change the determinant, which was very fortunate. Well, no, not so much. So I think I know what happened. Okay, but let's take it one bite at a time. Okay.
So we'll try to take that and turn it into row B, or to matrix B? Or are we just going to go on?
No, we're going to go on and do the other. We'll come back and see what happens. So here's a new matrix A and B. I thought they were talking about the ones from above, but they're not. Here's matrix A. Determinant of A here is 2, -3, 1, 4.
I like to do my 2.
Okay, they're lots of fun. That determinant is 11. Okay, here's matrix B doing its determinant, and its determinant is 1, 4, 2, -3. -11. Now, how did we go from A to B?
Switch the rows.
Switch the rows. And switching any two rows, or, and we're going to get this later, any two columns, which we haven't done before, those are not elementary row operations, but we'll get to them later. That changes the determinant by reversing its sign.
Okay, so if you switch the rows, you're going to get a different sign.
You get a different sign.
Even if it's in a 6x6.
Absolutely.
Switch one of the rows and it changes it negative.
Yeah, and it negates the sign. And the reason for that is that just like here, you do this minus this. When you switch the rows, it's the negative of this minus the negative of that. You're negating it. Okay? Because your diagonals are still the same. Okay, now let's do another one. Here a matrix A that we're going to find the determinant is a 1, -3, 2, -4.
-4 minus a -6, which is a +2.
Okay, you get -4 plus 6, yeah, 2. Okay, here matrix B is 1, -3, 0, 2. What do you get there? You get 2. Oh. Are those at all related?
Half of, no, you divided row 2 by 2. So you multiplied by half.
Okay, but that would be
No.
only 1 down there.
Yeah, it would.
And a -2. Double this row, add to that row, you're eliminating row 1. Minus 2 row 1 plus row 2. That gives you your 0, right? And minus 2 times that would be
Oh, it would be positive 6.
+6 minus 4 is 2. So that was the elementary row operation. Adding a multiple of one row to another row.
Doesn't change anything.
That is the one we use the most, and that never changes the determinant, ever. Changing 2 rows does change the determinant. Doing the more complicated thing, multiply one row by another, adding to it, doesn't change the determinant. Thank you very much. And that's what you did in A to get the B above. You never exchanged any rows, you just did that one elementary row operation, adding a multiple to another row, is my guess. I haven't gone back and done it, but my guess, that's why we turned out the same determinant. Okay? Let's do C.
One more.
Huh? Let's do C. Here's another A, and it's a 2, -8, -2, 9. Okay? What's its determinant? Oh, really? All right, yeah, I'm sorry. I dropped a sign. Okay. 18 plus 16, minus 16 is 2. Okay? And, yeah. And here is the B. I'm going to guess what it is. Divide the top row by 2, and you get 1, -4. -2, 9. So to multiply a row by a constant,
You have to multiply the
determinant by that same constant. And the constant happens to be a 1/2 here. Or to divide a row by a constant, divide the determinant by that same constant.
So try not to divide and try not to switch rows.
And basically most of the one we use is that middle. That when we're doing row reduction, we use that more. Yeah, if the order's kind of screwy, yeah, you move those. But you see that first one there, you had a 1 in the upper left. You can live with that and probably do row reduction from there on. And that's my guess of what they did.
You don't even have to have a row, any certain number anywhere. Just zeros in the bottom, right?
Okay, to get
the upper or lower triangle.
triangular. Okay, especially if you do an upper triangular, but it's a lot easier to have that
If you have
one. Okay, but notice the other diagonals aren't, so we could go back and do that, but I almost guarantee you did that. Now, the nose is clogging up. How are we doing on time?
15 minutes.
15 minutes, okay? And so far, knock on wood, no sneezing. Okay, so
What, just to mention it?
yeah, I had to mention it, didn't I? Okay. I did want to do something else here, just for funsies.
Funsies?
Okay. What happens now? This is not an elementary row operation. What happens if you divide this column by 2? Then you get
1, -8, -1.
Yeah, you get 1 minus 1 minus 8, 9. And what's the determinant of that?
9 minus 8, which is 1.
1, yeah. So you see, now that's not an elementary row operation, but again, same, yeah. Okay. So theorem 3.3 says the elementary row operations and determinants. Sorry. I'm having trouble breathing. Okay, let A and B be square matrices. Got to be square because you don't do determinants of matrices not square. When B is obtained from A by interchanging two rows, the determinant of B is the opposite or the negative of the determinant of A. We saw that. When B is obtained from A by adding a multiple of one row of A to another row of A, the determinants are exactly the same. And when the determinant of B is obtained from when B is when B is obtained from A by multiplying a row of A by a non-zero constant C, the determinant of B is C times the determinant of A. Okay. So basically, and here's a little shorthand they do here. We could have used it on this one. If you're talking about determinants now, you could have rewritten this as 2 times the determinant of 1 minus 4, negative 2, 9. Okay? In other words, when you divide a 2 out, in other words, factor it out, for the determinant purposes, it would be true of the matrix, but for the determinant thing, that's exactly what you're doing. So the determinants are sort of acting more like distributive properties and things like that, if you're dealing in determinants. They do a different one, but it's the same deal. They do a little proof there. Since you're a mathematician, you may want to look at that. You're probably not going to say a mathematician.
What?
Huh? Oh, I thought you were going to change when you get to 4-year school. Oh, you're going to stay with math now. Okay. I thought you were going to change back to computer science. No, okay.
Too many credits. I'd have to go, to get my bachelor's, I'd have to go for probably at least 5 years.
Oh, wow. Okay. All right.
I like math better anyway.
Oh, okay. You're good at both, but you seem to be such a whiz at computer. I thought you liked that better. Okay. All right. Before we move on, Augustin Louis, I think you pronounce his name Cauchy. I've never seen the phonetic spelling of that, but I believe that's what it would be. Pretty sure he was French. Okay. Often credited with bringing rigor to modern mathematics. He was the first to rigorously define limits. Thank you very much for that. Continuity, convergence of an infinite series. These are my favorite topics, but anyway. In addition to being known for his work in complex analysis, he contributed to the theories of determinants of differential equations. It is interesting to note that Cauchy's work on determinants actually preceded Cayley's development of matrices. So, goodness gracious, what was he working on if he didn't have matrices to do determinants? But it's interesting, these great minds, how they did operate. So anyway, there are several potential paper topics right there, okay? Cauchy himself, Cayley himself, then all these other things. Cauchy's contributions to limits or continuity or convergence of infinite series, complex analysis, theory of determinants, differential equations. There's a bunch of things you could do picking and choosing there.
I read an article recently about to see what it would take to bridge the gap in education from the 1600s and stuff like that to the 1900s.
Yeah.
With math and science, and what it would take to actually get us more closer up to date by the time you get out of required school or high school or whatever. It's pretty interesting because you don't really think about it, but a lot of this stuff is ancient.
Yeah.
But if you think about statistics, for instance, that's pretty relatively new.
Mm-hmm.
So I guess they're trying to figure out a way to kind of speed up the process to where we can get closer up to date.
Uh-huh.
While in high school.
Huh. Interesting. So let's do, seems like we're going backwards here, but let's do A, example 2. All right. Trouble breathing. Here's matrix A. 2, negative 3, 10. 1, 2, negative 2, 0, 0, negative 3. All right. Now, let's do it 2 ways. What would be the way you would be first inclined to do it? That's what I would do, okay? And so the first thing you do is determine the sign of that position. Plus, yeah, all your diagonals are plus. Okay, so that's going to be, it's a plus position, but it's a minus 3 in that position. And then you do your, wipe out that row and that column, and then you do times a yeah, 4 minus a minus 3, 4 plus 3. So that would be negative 21, right? Now, that was not too hard to do.
That was really easy to do.
Right. Now, what they're suggesting to do, I'm sorry, let's see. I forgot to play this way, so I'll use it again if I can find some dry area in it. It's not clearing a lot, but it cleared some. Still can't breathe.
And we're going into fall.
Yeah, and I have my flu shot already. Okay. What it's suggesting we do is perhaps reverse these 2 rows. If we're doing row reduction, that would probably be what we would do first, right? So that would be
1, 2, negative 2, 2, negative 3, 10.
1, 2, negative 2, 2, negative 3, 10, and 0, 0, negative 3.
And that would cause us to flip signs.
What's that?
It would cause the
Yes.
determinant to flip.
So the determinant of this thing, let's see, let's call this B. B is the determinant of B minus the determinant of A. Okay? Or let's do it this way. Determinant of A is minus the determinant of B. Okay? Doesn't really matter. Okay. What you going to do next? Row reduction wise.
2, row 1, negative 2, row 1.
Yeah. Negative 2, row 1, plus row 2. And that's going to produce 1, 2, negative 2. What do you say?
0.
0.
3, negative 7.
Okay. And then we'll leave this alone, 0, 0, negative 3. Now that hasn't changed the sign at all, so if we call this C, the determinant of A is the opposite of C because we did it to B. We didn't change the sign. Well, guess what we can do now? What kind of matrix we got? Yes, multiply those diagonals, and what do you get? 21. So the determinant of A is minus 21. And that's what we got before.
So the determinant of C would be 21, thus the determinant of A
Yes.
is negative.
Right. Yeah. All right, good deal. So is that any easier or faster? Not really, with all those zeros in there. But
Once you get to bigger matrices, or if you don't have a lot of zeros.
right, yeah, like that first day we had that was a 4x4 with absolutely no zeros. I think your row reduction would have been a very smart thing, because that's pretty easy to do, rather than having all those huge numbers like we had. So easy to make an error in it. Okay,
And we showed that too.
what's that?
We showed that on too.
Yeah. Yes. And we got time or not?
2 minutes.
2 minutes.
And you need to get going.
How's that?
You can end it, it's okay.
Yeah, I guess so. I probably need to go. So we'll begin next time on the top of page 114 and see the really bothering thing about one of them is, now maybe my first 2 classes may have uploaded to YouTube, but I still haven't put them in the playlist yet. But the this one, I don't know when it's ever going to get to. I'm going to take my computer with me, and if I have time, I'll set it up and let it be running while I'm doing interviews. But if not, then I have to do it this evening. If I have time this evening, if not, it's going to be tomorrow. So I hate it for the people who aren't here, but they should be here. Okay. With a little commercial message. Okay, I'll turn this off.
Don't forget to stop print screen.
Yeah. Such a delay there. And that.